dear students, this is Asha Didiji in front of you and I am a faculty with Vidya Bharati institutions. Currently I am working in Saraswati Vidya Mandir, Gumla, Jharkhand. Okay. So students, today we will see how to write electronic configuration. So for writing electronic configuration we have few rules to follow and they are, first one is Aufbau principle. Second one is Pauli's exclusion principle, and third one is Hund's rule. So in this video, line by line we will see all of these rules. So by knowing these rules we can easily write the electronic configuration. Okay. So you might be wondering what is Aufbau, what is Pauli, what is Hund. So let me tell you, these are the scientists' name. These are the scientists. Aufbau, Pauli and Hund are the scientists. They have discussed the way to approach how to write electronic configurations. So to honor them we have given the names of the scientists as a principle and as a rule. So let's look into the first rule, Aufbau principle. Okay. So here we have the principle for Aufbau. So it states that electrons enter into different suborbits in the order of increasing energy. It means what? If one suborbit has lower energy, then it will get filled with electron first, then the suborbit with higher energy that will fill later. Okay. So I have already told you about writing the electronic configuration in my previous video. Like we will write it as S. I find it very easy to write and very easy to remember. So you can also follow this. This is S, SP, SP, SDP, SDP, SF, DP, SF, DP. Okay बच्चों. Now अभी आपको क्या करना है? Just put here 1, 2, 2, 3, 3, 4, 4, 3, 5, 5, 4. एक छोटा, फिर 6, 6, 4, 5, 7, 7, 5, 6. So I have numbered these suborbits as 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5. So this is the way that you will write the electronic configuration. This is the increasing order. Like if you have to write the electronic configuration of suppose sodium. So sodium with atomic number 11. So we will write first 1s, 1s. Then after 1s, 2s will come. So we will write here 2s. Then after 2s there is 2p. So we will write it here 2p. Then 3s. Okay. Now we will fill the electrons. So as I have already told you that S has only 2 electrons it can occupy. So in S, 2p can occupy maximum 6 electrons. So it is 6. Now it is what? 2 plus 2, 4, 4 plus 6, 10. Now we need only 1 electron to fill as atomic number of sodium is 11. So we will put it here 1. So here this is the electronic configuration of sodium. Okay. So this way we can write the electronic configuration, and this way we can also satisfy the rule or principle of Aufbau, which said that lower suborbit will fill first. Okay. Now, how to get to know that which suborbit has lower energy, which suborbit has higher energy? This question might come into your mind, right? So let me answer it. So which suborbit will fill first? We will know this by the rule called plus L. By the rule called n plus L. Okay. So if any suborbit has lower value of n plus L, then that will be filled first. Then if any suborbit has higher value of n plus L, then that will fill later. Like taking the example of 1s and 2s. Okay. So 1s n plus L. Okay. So its orbit number is 1. So written 1. Now L, the value of azimuthal quantum number for S is 0. So S 0. Okay. Now 1 plus 0 is 1. Now coming back to 2s. Here in 2s the orbit number is 2. So n equals to 2 plus S suborbit has L value is 0. So putting here 0. So as you can see here in 1s, the value of 1s is 1 and 2s is 2. So we will put here, first of all 1s will fill, then 2s will fill. So 1s has lower energy than 2s. That's why first of all 1s will fill, then 2s will fill. Okay students. Now for your convenience I have written this. Okay. Now let's look into this chart. Okay. Now students, here in 1s the value of orbit 1s 0. So its n plus L value is 1. Since in all the suborbits 1s has lowest value, so it has the lowest energy. So first of all 1s will fill always. Okay. Now coming back to here you can see that ma'am there is the 2p and 3s and these have the same value of n plus L. Then how can we fill first? So if in case of 2p and 3s, if you will find same value of n plus L, then the second rule says you will see the value of n. In 2p and in 3s, since 2p has lowest value of n, that is 2, and 3s has higher value of n, that is 3. So 2p will fill first. Okay. So again 2p has higher n plus L, so it will first fill later. So 2s, then 2p, then 3s, then 3p, then 4s, then 3d. Okay. Here also you can see like in 3p and 4s. So here again n has 3 and its n has 4. So we have put here 4s later. Though their n plus L value is same, but the orbit number of 3p is less. That's why 3p will be filled with electron first. Only after 4s will be filled. Okay. Okay, students. So this way you can see that the suborbit with lower value of n plus L will be filled first. Then the higher value of n plus L value will be filled later on. Okay students. Okay, now by knowing this, let's write the electronic configuration. We will fill the suborbits on accordance with the lower energy suborbits. Will fill first, then the later one. Okay, now let's write the example of, take the example of calcium with atomic number 20. So first it will come here 1s, 2s, 2p, 3s, 3p. Okay. Now you all know that S has maximum 2 electrons that it can occupy. Okay. So 1s2, 2s2, p can occupy maximum 6. So 2p 6. Then 3s2, 3p 6 and 4s2. Now look at here. So it has completed its electronic configuration 20. Okay, done. This is the expanded way to write the electronic configuration. Now the condensed way I have also taught you, like first of all write their noble gases: helium, neon, argon, 2, 10, 18, krypton, xenon and radon and so on. Okay. So till 20, which comes first? Argon. 18 comes first. Is nearer to calcium. So we write here with 4s2. ओके बच्चों, देखो हीलियम, नियोन, आर्गन थर्ड में आ रहा है, तो we'll start with 4s only. So this will be argon 4s2. So these both are correct way to write the electronic configuration according to the Aufbau principle. We have filled the lower suborbits first, then the higher suborbits. So here you can write the electronic configurations by using Aufbau principle. Okay, now let's look into the Pauli's exclusion principle. Okay, now see here the Pauli's exclusion principle. It says that no two electrons of an atom can have the same set of all four quantum numbers. Means if you are taking the atoms of electrons of the same atom, then also it is not going to equal all the sets of quantum numbers. Okay, so let me take with one example. Okay, so let's take example of first suborbit. For the first suborbit, let's take example with of 1s, and here 1s1. Let's take example of here 1s2. Now let's find out the quantum numbers for this value. So for 1s, n will be orbit, n is the principal quantum number, orbit number 1. Now L azimuthal quantum number, the value of s is 0. Now n is the magnetic quantum number which gives information about the orbital, right? So for n the value is 2l plus 1. Now 2 into l is 0. 0 plus 1 equals to 1. It means we'll make one box only. So one box with, it starts with 0. So 1 is 1. 1 electron will put, 1 electron we have put. So 1 electron is put in the 0 box having 0 number. So n is 0. Now s is the spin quantum number which indicates the spin of the electron. Since our electron is filled and it is unpaired and it is up in upward direction, so its spin quantum number will be plus half only. Okay students, now let's move on to 1s2. 1s2 has n equals to orbit number, principal quantum number 1, its azimuthal quantum number s0, m is again 12 plus 1 value. So we will find out here 2 into 0 plus 1 equals to 1. 1 it means we will make one box. One box with number 0. We have to put 2 electrons here. So 1 electron and then 2 electron. So the second electron also put in the box of where it has the value of 0. So we will put here 0 and the value of s, spin quantum number. Here you can see the second electron that entered into this box, this energy box. So it is in the downward direction. So downward direction, it means the electron will spin in anti-clockwise direction, घड़ी की उल्टी दिशा में. So its value will be minus 1/2. So here students, you can see we have taken the first suborbit. These are the roughs, so I am just rubbing it. So Pauli's exclusion principle has said that you take the electrons of the same atom only, then also there will be chances that none of the electrons will have the same quantum number. Here you can see n is same, both the cases, l is same, m is also same, but spin quantum number got different. It becomes half and it becomes minus half. Okay bachcho, so it says that no two electrons of an atom can have the same set of all four quantum numbers. So here we have done with our Pauli's exclusion principle. Now let's check out into the Hund's rule. Now students, we will discuss about the Hund's rule of maximum multiplicity. Okay, so it states that pairing of electron starts only after filling all orbitals of same suborbit with one electron each. It means first of all you will fill the suborbits with one electron each, then you will start pairing the electrons. Okay, so let's take one example. Here, let's take an example of oxygen with atomic number 8. Okay, we know its electronic configuration is 1s, 2, 2s, 2 and 2p, 4. Okay, okay. 1s2, 2s2, 2p4. Now, how can we fill its electrons? So, say like this: s, 1s, 2s, 2p. We know p has 3 boxes, energy boxes of orbitals px, py, pz. So, we are writing here 2px, 2py, 2pz. Okay. So, for your convenience, I am taking one more example with again p, 2px, 2py, 2pz. P suborbit has 3 orbitals px, py, pz. That's why we have put 3 boxes. Okay. Now, S has 2 electrons. So, first of all, we will fill it with 2 electrons. 1, 2. Here also 2. 1, 2. Now, 2p4. There are 2 ways to fill this 2p orbit. First of all, we can fill like this. 1. Okay, let's see here. First of all, we can fill like this. 1, 2, 3, 4. Like this. Okay. Now, another way to write is 1, 2, 3. First of all, we have filled all these orbitals with single electrons. Then we are starting pairing. And it is 4. So, Hund's rule says that this is correct and this is wrong. Okay. Since we have to fill each suborbits, each orbitals with 1 electron, then the pairing will start only. Okay. So, let's rub it. Now, here you have the electronic configuration of oxygen and we have followed the Hund's rule of maximum multiplicity. First of all the orbitals get filled, then pairing starts. 1s2, 2s2, 2p4. The electronic configuration of oxygen. Okay. Now it has the second part also for the Hund's rule of maximum multiplicity. So let's look into that. Okay students, now the second part of Hund's rule of maximum multiplicity, it says that half filled or fully filled suborbit is more stable than incompletely filled suborbit. It means if you have D1 or D5, then who will be more stable? D5 will be more stable. Okay, like suppose let's write the orbitals 1, 2, 3, 4, 5. Okay, here also 1, 2, 3, 4, 5. Okay, now its orbitals are dxy, dy, z, dxz, dx square, y square, dz square. Let's write here also dxy, dyz, dxz, dx square, y square, dz square. So here students, we D1, so we will put here D1, D5, so put here 1, 2, 3, 4, 5. So students, the reason behind half filled or fully filled is more stable is that you can see here in D1 there is only 1 electron, in D5 there is 5 electrons which are filled, the 5 suborbitals. It is more symmetrical than D1 and symmetry leads to higher stability. That's why D5 is more stable than D1. Okay, and also you can see in the same case of D6 or D10 as well. Okay, so let's put here D6 and D10. So here by putting the electrons 6, 1, 2, 3, 4, following the Hund's rule. 5, now 6, pairing will start from 6, done. Now 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here students you can see there is less symmetry and there is in D10 there is symmetry. It is completely filled D suborbit and it is incompletely filled D suborbit. So completely filled D suborbit has higher symmetry and symmetry leads to the greater stability. That's why D10 will be more stable than D6. Okay students, similarly D1, D2, D3, D4 से ज़्यादा stable होगा D5 and D6, D7, D8, D9 से ज़्यादा stable होगा अपना D10 क्योंकि D5 half filled है तो more stable है incompletely filled से D10 fully filled है तो ये fully filled ज़्यादा stable होगा incompletely filled d orbital से. Okay students, so that it will easy for you to understand, so I am taking one example with which you can understand it better. So let's take example of chromium. Chromium with atomic number 24. Now let's put electrons here. 1s2, 2s2. अभी तक आपको याद हो जाना चाहिए है ना, इट इज इम्पोर्टेंट कि आपको S2P सब याद हो जाना चाहिए. ओके, सो राइटिंग हियर, मुझे इतना प्रैक्टिस करते करते याद हो गया इसलिए मैं फट से लिख दे रही हूँ. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. एक तो तरीका हुआ ये लिखने का, काउंट कर लेते हैं. 2 + 2 4. ऐसे इलेक्ट्रॉन्स को काउंट क्या करो, अगर 24 के 24 आ रहे हैं मतलब अपने इलेक्ट्रॉनिक कन्फिगरेशन सही लिखे हैं. ओके, स्टार्टिंग के लिए काउंट करना इज वेरी गुड. ओके, 2 + 2 4 + 6 10 + 2 12 + 6 18 + 2 20 + 4 24. तब आपको लगेगा दीदी जी यहाँ पे तो 3d4 हो गया, 24 हो गया, तब तो स्टेबल हो गया. बट हमारा हंड्स रूल क्या बोलता है, हाफ फील्ड और फुल्ली फील्ड ऑर्बिटल्स ज्यादा स्टेबल है ना. सो हियर यू कैन सी दैट 3d4 ये तो ना तो हाफ फील्ड है ना ही फुल्ली फील्ड है, ठीक है, लेकिन ये अभी इनकम्प्लीटली फील्ड है. 3d4 अभी हमने देखा था ना, तो इसको क्या d4 को हम d5 बना सकते हैं क्या? यस. सो we will write here 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 कर दिया और इसका जो एक इलेक्ट्रॉन था, एक एक्स्ट्रा इलेक्ट्रॉन वो यहाँ पे ऐड हो गया, तो क्या हो जाएगा 5. सो 4s1 3d5 will be more stable than 3d4. तो इसके बजाय हम लोग इलेक्ट्रॉनिक कन्फिगरेशन इसका लिखेंगे, क्रोमियम का. ओके बच्चों, यहाँ तक समझ में आया आपको? सो दीज आर द रूल्स फॉर राइटिंग द इलेक्ट्रॉनिक कन्फिगरेशंस. ओके, that Aufbau principle which told us about that the electrons will fill in the suborbits in the increasing level of energy levels of suborbits. Now Hund's rule says us that during the pairing of electrons, first of all each suborbit will be first filled, then the pairing will start, and the second part was half filled and fully filled suborbits are more stable than the incompletely filled suborbits. And also Pauli's exclusion principle has said that no two electrons of an atom will have the same quantum numbers. Okay students, so by knowing these three principles you can easily write the electronic configurations. Okay, so I want to give you one homework. So write the electronic configuration of manganese, cobalt, zinc and magnesium 12. Okay, so if you can write the electronic configuration of this by using the three principles, then I will get to know that you have understood how to write electronic configuration. So that's it from my side for this chapter. and all the best for your studies. Keep growing and stay healthy and stay safe.